Hi everyone, in this video I'm continuing to work through question 15 part C of the 2020 Extension 2 Barker College Assessment Task number 2. So it's a two-part complex numbers question. I've already worked through part 1 in a prior video, so take a look at that if you haven't already. And in this video I'm going to focus on part 2, which says, hence find the arg of z squared minus 3z plus 2 in terms of theta, noting that theta in the context of this question is the arg of z, and we've already just shown in part 1 that the arg of z minus 1 is equal to 2 theta, and the word hence in this part 2 gives us the hint that we're going to want to rely on that result. So let's take a look. So I've written out what we're being asked to show, which is this arg of z squared minus 3z plus 2. And noting that the hence means we want to rely on the result from part 1, that the arg of z minus 1 is 2 theta. And also I've recreated the diagram from part 1 with the information we worked out, because again the hence probably means that we might end up annotating this and developing on it further. So I think a natural place to start with this question is to make use of the fact that we know something about the arg of z minus 1. And so it's going to be helpful if we can rewrite this quadratic with z minus 1 as a factor, because then we can make use of the result that the arg of two things multiplied can be rewritten as the individual arg of those things added up. So I think as a starting point, what we can do is we can let our quadratic z squared minus 3z plus 2, let's let that be equal to z minus 1 times z minus some other constant I'll call k, and we just want to work out what k should be so that we've got these two factors. So let's expand the right hand side, so we'll get z squared minus kz minus z plus k, and then we can write that as z squared minus, it'll be k plus 1 z plus k. And then if we equate coefficients, we can see that here we've got minus 3 in front of the z, here we've got minus k plus 1 in front of the z. So we can say that the 3 will be equal to the k plus 1. So k is in effect 2. And that makes sense given we've also got our constant on the left-hand side being 2 and our constant over here being k. So k is 2, clearly. So, okay, therefore we can say that z squared minus 3z plus 2 is equal to z minus 1, z minus 2. And therefore the arg of z squared minus 3z plus 2 will be equal to the arg of z minus 1 times z minus 2. And as I mentioned, when you have the arg of two things multiplied, you can rewrite that as the sum of the individual args. So it'll be the arg of z minus 1 plus the arg of z minus 2. And there's our link to part 1, because we already worked out that the arg of z minus 1 is 2 theta. So this is going to be 2 theta plus the arg of z minus 2. And so now we just need to work out the arg of z minus 2 in terms of theta, and we would have worked out the solution to the question. So at this point, I think thinking about z minus 2 and what its argument would be, I think it makes sense to develop this diagram a bit further, because you may remember if you watched the video on part 1, I set up the argand plane so that the distance 1 had a very specific length. In my case, I measured it out to be 3 centimeters on my ruler, is the equivalent of 1. So we had this length being 1, and the distance from z minus 1 to z is naturally 1. And now if I want to go from z minus 1 to z minus 2, we can come back 1. And so that's going to be about this far. And you can kind of see the benefit of attempting to draw this to scale, because now we can see that z minus 2 kind of falls into the next quadrant, and so we should expect that when we work through the process, we should get an arg of z minus 2 that's at least 90 degrees, because we're going to come 90 degrees and a little bit further. So the arg of z minus 2 is the angle that this line here makes with the real axis. So if I just get a new color, it's basically this entire angle here. And we've already worked out part of it. We know from here to here is theta plus theta. So the question is, what's the rest of it? If we can find this angle in here, then we've got our arg z minus 2, and then we can add 2 theta, and we've got the arg that we're concerned with. So at this point, it's worth noting that in going from z minus 2 to z minus 1, that's a distance of 1. So in a very similar fashion to part 1, where we realized we were dealing with an isosceles triangle here, we've also got an isosceles triangle here, because these two sides have an equal length. And really what that means is that this angle and this angle are going to be equal. And to help with the working out, I might give that a letter. So maybe we'll call that angle A, just so that we can refer to it. And that means if we can work out this angle here, which I'll call angle B, then we'll be able to use the angle sum of a triangle to work out what A must be. And to work out angle B, I think we can make use of the fact that this whole angle is a straight line. So the angle sum of a straight line is 180 degrees, or pi radians. So I might call this angle C, and then we'll be able to start doing our working, because again, we've got a triangle here. We already know 2 of our angles, which we worked out in part 1, so we can find the third. That'll let us, so finding out C will let us find B, and finding out B will let us find A, and then we would have got there. So I might turn over at this point just to start working through this. So we'll start with C and we'll work backwards to A. So maybe over the page, we'll start by saying the angle sum of a triangle allows us to state that theta plus C will be equal to pi radians. Theta plus C is equal to pi, or 180 degrees. So C would be equal to pi minus the 2 thetas that we bring over. So that's C. So now using that, we can say the angle sum of a straight line will be 180 degrees also, or pi. So the angle sum of a straight line, using that, we can say that B plus C is pi. So B plus C equals pi. So B is equal to pi minus C, which equals pi minus 2 theta, which equals pi minus pi plus 2 theta. So these disappear, and we end up with B just being 2 theta. And now we can come back to use the angle sum of this triangle to work out A. So now we can say by the angle sum of a triangle, A plus B will be equal to pi. So B will be equal, actually we want A, don't we? So actually we should say 2A will be equal to pi minus B. So A will be pi minus B on 2. So that means A is equal to pi minus 2 theta on 2. And we can say that's pi on 2 minus theta. So that's A. And now that we've got A, we can get our argument of z minus 2, since we know that it's going to be this angle A plus 2 more thetas. So therefore, we can say the arg of z minus 2 is equal to pi on 2 minus theta, being A, plus the 2 thetas we already had. So that's going to simply be pi on 2 plus theta. The minus theta plus 2 theta gets us plus theta. And that hopefully makes clear sense based on our diagram, because as I mentioned before, we know we're going into the next quadrant, so we need something that's greater than 90 degrees. And here we've got that. We've got something greater than 90 degrees because theta is a positive angle. We know theta is a positive angle from part 1. So adding pi on 2 or 90 degrees gets us into the next quadrant. So that's a good sign that we got that. And now what we can do is we can put it all together. We can put our arg z minus 2 back into this result. So we can say, therefore, the arg of, what was it, z squared minus 3z plus 2. So we have z squared minus 3z plus 2 is going to be equal to the 2 theta we already had, plus what we just worked out as pi on 2 plus theta. So that will be 2 theta plus 1 theta is 3 theta plus pi on 2. Boom! And that's the end of that question. So we've got our arg of z squared minus 3z plus 2 in terms of theta and another constant, pi on 2. But theta is the only variable in there. And that's what we were asked to show. So there we go. That's how you tackle that question. Quite a bit to it, I guess. We had to first think to get our quadratic here with z minus 1 as a factor, knowing that eventually we're going to be able to make use of this result here so that we can then throw in our 2 theta that we worked out in part 1. So it was all about this linking word hence and thinking of ways we can incorporate this here. And then from there, I guess, to find arg z minus 2, we're really just rehashing the same technique we did in part 1. So whilst it's extra work, it's not really testing any new techniques. So yeah, hopefully that's all made sense and you followed along with all that, and it's all clear to you kind of how you could tackle a question like this. And tick boom.